All right, welcome ladies and gentlemen. This is our third video lesson for Algebra 2. This is on direct variations. This is a pretty short and sweet one with a few good examples there at the end, so don't miss out. All right, so what we want to do here is we want to figure out what is a direct variation and how can we write an equation of one. Well, nicely, a direct variation is one of the most simple linear equations that we deal with. It's a linear equation in the form y equals k times x, where k cannot equal 0. In this particular graph, or this equation, the y-intercept is 0, 0, so it goes through the origin on your coordinate axis. K is called the constant of variation when we deal with these as direct variations. If we think of it as a linear equation, it's also the slope of the line. So if we were to look at a graph would look something like this. It would go through the origin, and it would have a constant slope, and the slope of that line would be k. So essentially we're going up k and right 1. Up k, right 1. And k is any number as long as k is not equal to 0. In words, it is written normally as y varies directly with x. Sometimes we can replace with the word as, so we would say y varies directly as x. This works in word problems, so we can write equations for this. But the nice thing here is when this says y varies directly as x, it literally means y varies directly, so it's k times x. And it's exactly as this is written, is exactly what the equation is up here. Y varies directly as x, or with x. All right, so there's some things that we can do here. First question would be, is it a direct variation? And so if I was to make a table of values, and I would say, okay, this is my x, this is my y. If I had the numbers 1, 2, and 7, and I'd said 9, 18, and 63, in order to determine if this table is a direct variation or the table of a direct variation, what we need to do is we need to say, if we were looking at the equation, let me backtrack a little bit here. If I was to look at the equation y equals k times x, since k is a constant value, I can solve for k by dividing both sides of the equation by x. And I could say k is equal to the value of y over x. Well, that's important because if y divided by x is always the same number, then this is a direct variation. So I can do all of these things. I need to do y divided by x for all three of these coordinates. So if I did 9 divided by 1, that's equal to 9. If I did 18 divided by 2, that's equal to 9. And if I did 63 divided by 7, that's equal to 9. So the answer for this one would be yes. This is a direct variation because all of those values, all of those ratios are exactly the same value. So then the question is, if yes, find the constant of variation. Well, the constant of variation is that y divided by x, which we just found to be 9. So if we were to write the equation then, the equation for this line would be y equals 9 times x. And that is that. That is all three parts to this question. So the question was, is it a direct variation? Well, we determined it is. We said, okay, since all of those numbers are the same, that is my constant of variation. And then I can write that as an equation. So if I was to then make a slightly different problem here, if I was to say x and y, and I had 1, 2, and 9, and I said this is 3, and this is, let's go with a 4, and then in 11, I can determine that this is actually a linear equation, but in this case it's not going to be a direct variation because when I do those y divided by x's, I get 3 over 1, which is 3, 4 over 2, which is 2, and 11 over 9, which is just 11 over 9, and I don't want to figure out what that is as a decimal. Those are all different values, so this is not a direct variation. All right, let's look at something else. We have different types of equations that we can ask here, and all types of equations, or all type of questions, are important to understand how to do them. So the first one would be, for a direct variation, find the constant variation and the value of y when x is equal to -3. So let's say y is equal to 2 when x is equal to 7. So for a direct variation, this being the direct variation, y equals 2 and x is 7, I can find the direct variation here. So I can say the k value is equal to y divided by x. So I can set up my equation and say y is equal to 2 over 7 x. And since I want to know what is the y value when x is -3, I'm going to plug the -3 in for x. And I get a y value of -6 over 7. Now, this is one way to solve this problem. What I want to do is I want to show you a slightly different way to solve this problem using proportions that you might remember from Algebra 1. So using a proportion, since I want to know the y value when x is 3 and I know y is 2 when x is 7, we can think of the idea that k is equal to y over x. And k has to be the same for both coordinates. So we can say 2 over 7 is equal to, so this y divided by this x has to be the same as this y up here divided by this x here. Now this way is probably a little more simple, but I wanted you guys to understand that you can write an equation and solve it that way. This requires cross multiplication now, so I get 2 times -3, which is -6. And I get 7 times y, which is 7y. Divide both sides by 7, I get, again, -6 over 7. And there we go. We get the same answer using two slightly different ways to solve this problem. This one is a pretty simple one if I want to write an equation for the direct variation that passes through the point. Let's say it's the point, let's go with 1, no, let's go with 2, 2, 7. Okay, if I want to write the equation for a direct variation that passes through this point, I need to find k. I need to find the k value, so k, we know, is y divided by x, so in this case it's 7 divided by 2. So therefore we can say y is equal to 7 over 2 x. And that's actually it. That's as easy as this one gets. I mean, there's nothing else we can do about it. All right, let's try something else here. There's, I think, 2 more here. So here's one of those good questions. It's kind of the same thing as the first one, but I wanted you to see the different way the question can be asked. So here it says y varies directly as x, or directly with x. And it says if y is 3 when x is 9, find x when y is 4. So what I'm going to do here is I'm going to use the same idea that I did with the first one, or the second idea, where I'm going to use a proportion. So I know, remember, k has to equal y over x to make a direct variation. And that means that 3 over 9 has to equal the other y over the other x. So this other y over the other x. And since I don't know what the x is, that has to be my variable piece. And since this is a proportion, we can cross multiply. We get 3 times x and 9 times 4. And I need to solve for x, so I need to divide both sides by 3. And I get x is equal to 12. And that's the whole question. The question was find x when y is 4. So this is the x value when y is 4. Okay, another one here. Determine if it's a direct variation. So let's get a thing here. Let's say m, you're given some slope is -5/6, and you're given a coordinate that looks like this. So the question now is this a direct variation? So if it's a direct variation, the m has to equal a k value, and the k value has to be y divided by x. So I need to determine, is -5/6 the same thing as -12.5 over 15? So I can just say -5/6 equals -12.5. I don't really like it like this, but I'm going to keep it like this, over 15. And then the question is that a true statement? Is this equal? Well, if this is equal, we can cross multiply and get the same numbers. Okay, so I'm going to move over here to the left. If I cross multiplied, I would get -5 -5 times 15. And I'm still asking myself that question. 6 times -12 and 1/2. All right, -5 times 15 is 75. And I can go 6 times 12, which is 72. Sorry, I forgot the negative here. 6 times 12 is 72. 6 times 1/2 is 3. 72 plus 3 is 75. And they are equal. So the answer is yes. By using that proportion, we solved that this is a direct variation because the value k is equal to the value of m here. All right, last question here I'm going to ask. We're going to choose a value of k from a given range, and we're going to write the equation and graph the line. All right, so we're going to say, let's say that 0 is less than k is less than 1. Now, everybody's example or everybody's answer to this could be different because there's infinitely many numbers between 0 and 1. But I like to choose good numbers. So I'm going to choose a value of k between 0 and 1. And I'm going to choose the k value 1/2. Okay, it's as simple as just choosing a good number from the range. And then I'm going to say, okay, if I wanted to write the equation, I'm going to say y is equal to that k value times x. Okay, so now I've written the equation, so that's that part. I chose a k value, I wrote the equation, and then I'm going to do a simple graph. Right? So we know that it has to go through the point 0, 0, because direct variations always do. Then we're going to up here and we're going to go rise 1, run 2. So my slope is 1/2, so I'm going to go up 1 and right 2. And I'm going to connect those dots using a straight line. And I'm going to call it good. All right. Make sure when you're drawing straight lines that you use a straight edge, like the edge of your ID or your phone or a ruler, um, and anything like that. All right, so that's going to finish us off. I hope you learned a little bit of stuff, and I will see you guys later.